Okay, in this video we're gonna design a vacuum tube OR gate that uses, well, basically diodes that are directly from the other way of making them, using the newer kind, the stuff that they replaced this type of tube with when they stopped making it. When they went to transistors and stuff like that, they used diodes. They could make transistor OR gates too, but the simplest form to do it is use two diodes, resistor, and an LED. Or you can just use two diodes and a resistor. If it outputs, if the LED lights up. Anyway, we got two diodes here. The anodes are here. And they don't call them anodes on the tube, they call it a plate. The other thing they call cathode, which is correct. So the plates would have to be your inputs, and then your cathodes on your tubes tie together. Then go to LED to ground. Anyway, it's very simple. And I'm probably gonna be getting more of these tubes here to make another type of logic gate called an AND gate, and then we're gonna make one that does the XOR gate, which is like, or except when both are true, it comes out false. So let's get started. Here we got we got this here is positive. It goes to USB cord going into this power strip that has a USB plug on it, and the negative's right here. The filament, they say to 6.3 volts, but it works just fine at 5 volts. It's probably even healthier for it to work at 5 volts, considering that you're not putting that much stress on the heater. It may not have the best current coming out of it because it's a little less than that. You don't want to go less than 5 volts probably. If I go less than 5 volts, it probably won't turn on, and it probably won't do things right. So anyway, there's a green LED on there that's not on right now. That's because all the switches there are all outputting low. And if I turn one switch on, it should turn on. Let's see if it does. And see, there you go. It turned on. If I turn that one off, it turns off. If I turn this one on, it turns on. Off. And if I turn both on, it does something kind of funny. Watch. I don't know if you can see that. It gets wider and darker. It gets wider than it did with just one on. Well, my guess is because it's parallel. It's going in parallel, and that's light out more current than the other way. But diodes don't usually do that with regular silicon diodes, I don't think. At least I haven't seen that one happen. It may, who knows. As you can see in there's a little red glow, and that's the heater. And how I was watching this video from this other guy on YouTube. He got the tubes looking at like 6 volts for the heater, and then he was using 12, I think it was 24 volts for the testing for using the diode. Luckily, I was able to test it at 5 volts and use the same thing. Probably does work at 5 volts. Probably because it would have to. Because if the AC is going up, you want it to be on at 5 volts when it's at that 5 volt area. You don't want it just to majorly drop out at where your low voltage is. Because then it won't be a very good rectifier. This here says twin diode. That's because there's 2 diodes in one tube. That's why I only got 1 tube there. They have some tubes that have 1 diode on it, and then they have less pins. Like I think it's 3 or 4. Yeah, it has to be 3 pins. on some of them, and some will fire 4. This here will make a good. Then so this make a good logic testing experiment. You can make computers out of this and stuff like this if you get enough of them. And then I was reading the data sheet. It says heater draws like 30 milliamps on it. Not 30, 300 I mean. The rectifier on it that said for the plate current, which I believe is what the current that it must be like a diode, like would be the current rate of a diode, like a regular one of these diodes would be called plate current. And it's only like 54 milliamps. That's not very much. At least one of your diodes you get from Radio Shack or so are like 1 amp or so. Which is like, I don't know, like quite some order of magnitude higher. Oh yeah, and these switches here, the 3-way switch. These 2 switches here. You can use a 3-way switch or you can use a single pole double throw switch. What they do is they switch the polarity of which these here are getting. Why I done that was so that if I could add more of these tubes on it and do different logics on them and stuff, it would have the right polarity and always light of polarity instead of a positive and then nothing. Because you do AND gates on it, if you have to have a negative to turn for it to can't have nothing there. Otherwise it'll act like not what it's supposed to be doing. You could use a pulse resistor, but the thing is, pull down pulse resistor. But the thing is, it probably you have to play around with that stuff. So it's probably best to just use these type of switches. And that's at a lower voltage rating. These tubes usually, I heard they're supposed to go really high on that in order to work. Which is amazing. I only got one from eBay, but I'll probably end up getting like maybe 3 more. I'm gonna probably go to Amplified Parts, or that one place I found, and buy one from there. I think there's only one left in stock on that one place. Because I was get like 2, add 2 on it, and it told me that there's a send mail one off, and then mail the other one that comes in stock. But for the AND gate, you're exactly the same thing. You just need one tube for the AND gate. And that would because that's what you can do with diodes. They call this DL, diode logic, it stands for. It's not the best logic thing to use. Cause sometimes there's drops on it. Then also if you do it to a whole bunch of them, like let's say you had a whole bunch of circuits that had like AND OR and a whole bunch of logic gates that goes through, it's gonna drop it out. Adds up, even though it's like what, like a 0.6 volt drop. And that's how one of the. But the thing is, with what we're doing, it doesn't really matter. In fact, I don't think it's dropping it hardly anything. I'm not for sure. There probably is a drop. on it. I'd have to measure the meter and see what we get on the output. And I got this nice floor tile here I've been using for my circuit boards. That because this new floor tile they have put in here, this is extra left over that they cut off of it and they didn't have no use for it. So they gave it to me so that I could have it, and so I decided to use it for making circuit boards. It's vinyl, which is a good insulator. You know, it doesn't really matter what voltages I'm using. The vinyl is usually used in like electric tape, I believe, if I'm not mistaken. And it's pretty neat that the light turns on in there. And that's amazing I could do it at 5 volts. I was worried that I had to get another power supply. Or another couldn't run off the 5-volt waves with the signals into it. I don't know about the XOR gate. What I have to do, I have to measure. First thing I'm going to do is measure the voltages on there, see what's coming out of it when it's on. And when it's off, it must be completely off. So it couldn't be. I don't know if it's outputting a negative voltage. I don't think it would, since it's a diode. It's probably outputting doing what these diodes here do. It's going to output positive or nothing. That's basically it. Well, thanks for watching. If you like it,